Over the course of the last few classes, we've gone over how to find the slope of a line when given some points, how to find the slope of a line when given an equation, how to find the slope of a line when given a table, and how to draw those lines from equations, and how to find the slope when given points, how to find the equation when given points and when given slope. And we've done all the same with inequalities. In this lesson today, we are going to go over how to identify changes to our linear parent function. And if you don't know what that is, that's okay. I'm going to explain it to you as we go along. All right. So first, let's go ahead and get started with our essential question for the day. And that's going to be right here. How can I oh goodness, I don't know why that's typing so strange. All right, how can I identify and graph transformations of linear functions? All right. Now, if you are unsure what that stuff means, that's okay. I'm going to give you a brief overview of all of it. We've been doing linear functions. Those are just functions of a line. That's what that linear portion means. And a transformation of a linear function would be it shifting up or down, changing its slope, whether it be positive and going to negative, or starting at negative and going to positive, and also it becoming more or less steep. All right. All that stuff changing uh, is what we mean when we say identifying transformations of linear functions. All right. And so let's think back not too far, because we have just been doing this. The equation for this of our slope intercept equation. That's what I want to say. What is our slope intercept equation? And if you recall, it's going to be y equals mx plus b, right? And I'm actually going to put this whole thing in black. That is our equation, our slope intercept equation. And then we have this thing called a parent function. And what we mean when we say parent function is the function of the equation that was the original. All right. So before we make any changes to our equation, the original is going to be y. Let's use, I'll keep using the same color, keep using black. Y equals x. That's going to be our parent function. So y equals x, okay? And so what that equation is, if you think back to this example that we've had a few times, this equation, and we will have it below as well, this equation is just a diagonal line going through our origin with a slope of 1. All right, so here we don't have a number next to this graph, and so this is going to be, this has a slope of 1, which is going to be right here. And this is just for you all to help you all think about it. We have a slope of 1, and then we also have, in this one, our y-intercept is going to be 0. So we have a slope of 1 and a y-intercept of 0. Okay, and that's that's going to be the basis of this entire lesson. When our slope is 1 and our y-intercept is 0, how does our new function change? So this is our parent function. This y equals x. It has a slope of 1 and a y-intercept of 0. You could write it out like y equals x plus 0 if that helps you think about that slope intercept form, and then having our intercept be 0. You could write that out. That would help. That may help. I'm going to not do that because it's going to be more writing and stuff I have to do later on. But let's move on to this next portion. It says, when we change the parent function of a line, we are transforming the graph. What do you notice about the following graphs? Compare f of x and g of x. Now, Try not to let this trick you up too much. We did cover this in our last unit, how we can write f of x and just replace that with y and vice versa. So y is the same thing as saying f of x, and g of x is the same thing as saying y. But since we're working with two different functions, we don't want both of them to be y equals this and y equals that. So we gave them two different names. So f of x is going to be our parent function, and g of x is going to be our transformed function. That's going to be the function that has a different slope and a different y-intercept than 0 and 1, or than 1 and 0, respectively. So let's look at number 1. Number 1 says f of x equals x. That's going to be this equation in red. And here I'll underline it in red so you all can make that connection a little easier. So this is going to be in red. And then I don't know if I have a blue color. I don't. Not a good one anyway. And this is going to be in blue. So if you look at this parent function, that's f of x equals 0. If we were to find this, it doesn't have a y-intercept. So that's going to be starting or going through 0, starting at 0. Then we're going to rise 1, run 1. Rise 1, run 1. All right. That's how this one is. That's what our parent function looks like. Now, when we look at our transformed function, this one still has a slope of 1, just like the one we just did, rise 1, run 1, but it has been moved up 3 units, okay? It's been moved up 3 times. This portion here, where's my pin hit? There we go. This +3 indicates to us that it has been moved up 3 times. And if we look, we started at 0 for our y-intercept, and then boop, boop, boop. 1, 2, 3. We've moved up, and we still have this slope of 1. So we rise 1, run 1. Rise 1, run 1. All right. That slope is the same, but we have shifted 3 units up. Okay. And so that's the difference with this graph. And I'll write in a different color since I know this one is hard for you all to see. Actually, I'll just type it out. So for this one, what we notice for this one is that g of x has shifted up 3 units. If you notice something else about this graph besides what I've just told you, by all means, let me know. Come back to the Zoom chat and say, hey, Mr. Williams, I see this and this happening. Now let's look at this next one. Number 2, once again, we have this parent function written in red. I'll underline it again just to help you all grasp that. And here it is in red. It starts at 0, 0. Our parent function for our linear functions will always start at 0, 0, as 0 being our y-intercept. They don't have a slope of 1. So rise 1, run 1. Ooh, that's a bad dot. There we go. Rise 1, run 1. Rise 1, run 1. Rise 1, run 1. That's a tongue twister. Try saying that 4 times faster. All right, and now that we see what our parent function is doing, if we look at our transformed function, which is going to be the one in blue, this g of x, our transformed function, that has been shifted up 5 units, okay? We have a b of 5. For this, our parent function, we start off with a b of 0. But then for this transformed function, we end up with a b equals 5. All right. So that's a major change in these things. So we start at 0, 1, 2, 3, 4, 5. Here we go. We see that b is now 5. And so what we notice about this function is that g of x has shifted up 5 units. Instead of retyping all this, I'm going to copy and I'm going to paste. So g of x has shifted up 5 units, all right? Now, when we look at number 3, I don't even think I need to tell you all what's going on. This one, we see it shifted up. We see +3 and it shifted up 3. Number 2, we see it's plus 5 and it shifted up 5. Number 3, I don't think I got to tell you. I think y'all are going to be catching on here soon. If not, go ahead and ask me, what is number 3 doing? You look at the parent function and then look at the transformed function and tell me what's happening. All right. So when we look at these, the major thing that we notice is that B where is it at? Here's my cursor. B, oh, that's an ugly B. B shifts up or down. All right. That's how our parent function is going to change when we include a B. Our B will shift up or it'll shift down. Gotcha. Okay. Get it? Got it? If you don't get it, you don't got it, come let me know. Now let's look at some more graphs, some more examples. This says, what do you notice about the following graphs? Compare f of x and g of x. Once again, f of x is just another way of writing y, and g of x is also another way of writing y. But since we don't want y equals x and then y equals 2x, that would be confusing when we're trying to figure out which equation we're talking about. We're going to instead use f of x and g of x. And then you can put like any letter there. It could be h of x, p of x, q of x. Anything could go there. But let's look at this. Number 1 says f of x, our parent function, equals x. Our parent function equals x here. I'll underline this in red so you all can see that's what I'm talking about. And then we have this transformed function, g of x equals 2x. So our parent function in red starts at 0, 0 because we don't have a b. Our b is equal to 0 here, and it's also equal to 0 in our transformation function, our transformed function. But what we do see is a change in this slope. Before we had a slope of 1 in this parent function. So here, let me write that instead. Instead of writing b equals 0, we'll go ahead and we'll write m equals 1. And in our transformed function, we have m equals 2. Now, if that's confusing, let's go ahead and look at our parent function, this red line here. All right. We start at 0, 0. Put a dot there, but we rise 1, run 1. Rise 1, run 1. All right. Rise 1, run 1. You'll have that the entire way through. Now, when we look at this transformed function, we still start at 0 because our b is still 0. But to get to our next good point, which is going to be here, we got to have to rise 2, 1, 2, and run 1. Okay. Rise 2, run 1. Rise 2, run 1. And that would give us a slope of 2 over 1. But once we simplify, we would get a slope of 2. All right. So that's how we get our m equals 2. And that's how it has changed from our parent function to our transformed function. Now let's look at number 2. Number 2 says f of x equals x. Once again, we have this as our parent function, and this will always be our parent function when we're dealing with linear equations. F of x equals x. We have that slope of 1 again, and I'll just go ahead and do that with this right over here. We have a slope of 1 again. Now, when we look at g of x, we see that instead of having a whole number, we have a fraction here. In this case, when we're dealing with slopes and things, fractions are our friends. Fractions make this stuff easy. So in our parent function, we see we go up 1 over 1, up 1 over 1, up 1 over 1, rise 1, run 1. That's the slope that we're used to. Now, when we look at this transformed function, we see we have a rise of 3 and a run of 4. All right, so if that's something you guys aren't remembering, slope is going to be rise over run. Rise over run, so a rise of 1 and a run of 3. So let's look at our original, or not original, at our transformed version. We start here at our origin and we rise 1 here, so that's going to be a 1, and then we go over 1, 2, 3 before we get to our next good point. All right. So there's going to be a rise of 1 and a run of 3. If we could start at another good point here, and then it'll be a rise of 1 and a run of 3 before we get to our next good point. And that's how this parent function has transformed into our new function. It has a different slope. Now let's look at this last one here. G of x equals negative x. This one is actually very interesting because our slope, the number value is the same, but the sign has changed. So instead of it being m equals 1, we have a m equals negative 1. And I forgot to write the slope for this one, m equals 1/3. All right, on this number 3, our parent function has a slope of 1, but our transformed function has a slope of negative 1. And anytime we have a slope of negative 1, that's just going to be going down left to right, okay? That's going to be decreasing, going down left to right. Now, when we look at all of these, slope is, I always like to think of it as how steep our steep is. It's a measure of steepiness. The greater, the higher, the larger the number of our slope is, the steepier it is, and the smaller our number is, the bigger that fraction, the less steep it is. And so when we have a whole number other than 1 be our slope gets more steep. And then we have a number that's less than 1 be our slope. We have a slope that's less steep. You see how this 1/3 is a more shallow steepness than this 2 or even this 1? That's what happens when we have a fraction as our slope, okay? And then when we have this negative sign, it just boop, turns the other way, it becomes negative. Our slope becomes negative. So moving on down to this next part, this says, suppose I should write this one out. M, which is our slope, makes the graph steeper. Oh goodness, that's not how you spell steeper. I'm gonna try and write neater. Makes the graph steeper, S-T-E-E-P, steeper or less steep. If m is negative, like we saw in that third example, the graph is going downhill. All right. So if you look at this number 3 again, first the graph is going uphill. It's rising, it's positive, it's going up from left to right. But when we look at our transformed function, it's going downhill. It's negative. All right. It's going down from left to right. So let's look at a few more examples. Our directions say to describe the transformation of the following functions compared to the linear parent function, y equals x. So let's keep that in mind. Our parent function is y equals x. And I'm not going to do all of these. I'll probably do like 3. Because I think once you get it, you'll get it. Once you start to get it, you'll have it. All right. So let's look at number 1. We have y equals x minus 1. Anytime we still have that x, no coefficient to x, our slope is going to stay the same. It's going to be 1. And anytime our b is changed, we're going to look at our sign to say whether it's being shifted up or down. And then we're going to just put that value. So up or down, however many units. This is minus 1. So this is going to be shifted down 1 unit. Right? When we look at number 2, actually, I'm going to skip to number 3. When we look at number 3, we see how this is shifted in the direction. It has a plus, so it's going to be shifted up somewhere. And then it says plus 4. This 4 right here tells us it's going to be shifted up 4 units. Now, when we look at number 2, this has a slope other than 1. This has our slope being 6, and anytime we have a slope different than 1, that's or a slope higher than 1, a slope that's greater than 1, that's going to be when we have our parent function is going to be steeper, or our transform function is going to be steeper than our parent function. And our parent function is y equals x. Okay. Now, when we look at number 4 looks a wee bit confusing. It has y equals negative 2x. But remember, when we have a slope of negative, that's just it going downhill instead. So this, we're going to start off by saying this is going downhill. And then how is it going downhill? Is it steeper or is it less steep? This has a value other than 1. That's a negative 2 right there. So since it's going downhill, it's also going to be downhill and steeper than y equals x, than our parent function, okay? So I think you all can handle 5, 6, 7, 8, and 9, the rest of them here. When you get to 7 and 8, you're going to have to distribute appropriately and then tell your descriptions of how the graph has transformed from the parent function. Now let's look at a couple other examples, a couple of word problem examples. The first one says, excuse me, the function f of x is shown on the graph. Plot 2 points on this grid to create the graph of the line that will represent f of x plus 3. So this is asking us to shift our graph 3 units up. All right, this plus 3 tells us we're going up, and then this 3 tells us we're going to go up 3 units. And to do this, the way we're going to start is by identifying our first y-intercept. Our first y-intercept here is going to be this -1. And since we got to shift up 3 units, I'm going to start off by plotting a point that's 3 units higher. So from -1, I'm going to go up 3. 1, 2, 3. There goes my little point. And now I need to know the slope of my parent function here, which is this one here. So let's put a dot here and a dot here. These 2 dots I'm just going to use to help me find the slope. When I calculate my slope from this graph using these dots, I see I'm going 1, 2, I'm going up 2 and boop, over 1. So I have a slope of 2 over 1. And since I'm trying to just move this function up 3, I'm going to continue that same slope using this pink dot. So from this pink dot, from my transformed dot, I'm going to go up 3, 1, 2, 3, and over 1. I can keep on going, but I don't have much graph above me. And so what I'm going to do is draw a line using my line tool. And I'll make this line pink. All right, so going through that slope. Oh, goodness, y'all, I counted wrong. That's not 2, that's up 3. Let me recount correctly this time. So going up 2, 1, 2 over 1. And then if I did it again, up 2 over 1, I would run out of graph, but it'll be somewhere up here. All right. And I'm going to draw my line through my graph. All right. And the way you can tell you've done it right is that your slopes should be the same. Your lines should be parallel. They should be shifting the same way unless that slope has changed. Since this slope hasn't changed, these are going to be parallel. So let's look at the next one, the next example. I want you all to do this example. I'll go through it and kind of get you started on it, but I want you all to do it as well. This says the function f of x is shown on the graph. Plot 2 points on this grid to create the graph of the line that will represent f of x minus 2. So you're going to start with your y-intercept, and then you're going to do what this transformation is telling you to do. All right. If you're struggling trying to figure out what this is telling you to do, then come ask for help. Otherwise, do this, turn it in, and get started on the classwork. Once you are finished running through the notes, go ahead and in this summary section, just kind of sum up all that we've done in this lesson. Um, answer the essential question. And if there are any points that you've gotten stuck on and you need more help, you can go ahead and write that down here and like just kind of highlight it as your muddiest point. All right. Once you're finished with this, go ahead and get started on the classwork and we will go over that stuff later. All right. And if you have questions, please come back, ask, and let me know. All right.